Alright, I'm going to be doing problem 4.31, and that's in perusal as part of my project. And so if we look at we're going to start with number one. We're going to find all the critical points of f by finding when df xy is the zero matrix. So I'll show you what that means. So what you got to do is you're going to want to we're going to want to solve for the gradient first. So we can get like the x and the y, both of the gradient like by themselves. So gonna do that. Gradient of f, and let's do the x's first on the x side. And so with the gradients, we want to make sure that the y's are going to be treated like constants. So this is going to be 2x. We'll make that plus 4y, because y is now going to be a constant. Alright, but that should be good right there. But for the y side, we can now make x the constant. And so it would be 4x plus 2y. Alright, there we go. And that's great, the gradient. So we're going to want to make these two equal to 0, 0, 0. Because now that this is basically a derivative, if we want to remember that in first semester calculus, whenever the derivative equals to 0, that means it's going to be a critical point. So that's exactly what we're looking for. So let's make 2x plus 4y equals 0. I'm going to want to separate those two. And now 4x plus 2y equals 0. So what we could do to solve for the x or the y, we could use substitution to solve for y, put it in the other equation. But a cool math trick, what we can do is we can actually change one of the equations in a certain way. So we want to make sure that one of these variables has the same coefficient as the other one. So say this 4x, for example. We want to make this a 4x. So the way that we would do that is we times this by 2. So what we're going to do, we're going to make all of this times 2. So it's going to be 4x plus 8y equals 2 times 0, which is just 0. Alright, cool. Now we can just move this along, move this back. So 4x plus 2y equals 0. Cool. And with that, what we can do, we can scratch that off. So yeah, so this is the metric. The reason why we wanted this together is because when we subtract everything together, that's just going to be a lot faster. So 4x minus 4x, that equals 0. So now we have isolated y. And so now 8 minus 2 equals 6y equals 0. So as you can see, y equals 0. That's going to be super helpful, because we got to find the critical point of f, points of f. So we already got the one value of y, and since we already have the equation, we can use one of these equations, 4x plus 2y, to find out for x, what does x equal. So what we can do here is let's make 4x plus 2 times, and then now we already have the y, so we can put the y right here. So 2 times 0 equals 0. Now let's solve for x. I see this is 0, and so it'd be 4x equals 0. So x also would equal 0. So this is the only critical point on the graph. And so it'd just be 0, 0. Sweet. And that's how we do the first one. So now we've got to find the eigenvalues of d2f, d squared f. So let's do this on a different one. Alright, cool. So for this, number 2, find the eigenvalues. So we've got to do is we got to use the gradient that we already had. Let's see, so it's going to be like that, 2x plus 4y. 2x plus 4y. And then it was 4x plus 2y. 4x. All right, cool. Now that's the gradient. So this is the first derivative. So, but for the second derivative, we're going to make now a matrix. And so if we can make a matrix like this. So on the left side, just like when in a gradient or just like in a point, the left side is always going to be the x values. And the right is going to be the y values. So that means all this right here, whatever we're going to do to this, all that's going to be in this area right here. And this area, these things, is going to be in this area. Cool. And so let's do now the derivative with respect to x on this side. And so what that will be is just going to be 2. Because these y's treated like a constant again, so that's going to be 0, and then that's going to be 2. So just 2. And now let's go to the y part. So that's going to be right here, just 4. And x is going to be treated like a constant. So that's for this side. Now we do the same thing for this side as well. So this is going to be 4. And this is going to be 2. And the way that we find the eigenvalues, as we learned before, is we're going to take advantage of all these numbers. So we're going to do 2. And with these cross ones right here, we must remember that we need to do 2 minus lambda, and that times 2 minus lambda. And that lambda sign, that when we're solved for that, that's going to be the eigenvalues. So now we took care of these, but now we need to subtract by these corner ones right here. So subtract 16. We'll make those equal to 0. So let's first factor this out. So this would be 4. And this is going to be minus 4 lambda. And that plus lambda squared minus 16 equals 0. And what I'm going to do, I'm going to reorder it to make it look a lot nicer so the x squared's in front, and also simplify the 4 and the 16. So this is going to be lambda squared minus 4 lambda, and that minus 12 equals 0. So now let's factor this out real quick. I'm going to make that to, so what this would be theta minus 6 times theta, not theta, lambda. Man, the Greeks, they're changing me. And that minus 2, or plus 2 actually. So one way you could see that is 6 times 2 equals, negative 6 times 2 equals negative 12 right here. And then negative 6 plus 2, that's going to be negative 4 right there. So that equals 0. So for the eigenvalues, that would just be when lambda equals 0. Oh, when you want to make it solve equal to 0. So this would be 6, and this would be negative 2. So those are the eigenvalues. And because one is positive and one is negative, we can look at perusal, the little hints that Brother Woodruff gave us. If one's negative and one's positive, it's going to be a saddle. So that's something that we can remember. So the answer to that is legit going to be a saddle. And this will answer number 3. So it's going to be a saddle. And that's the value of f is going to be the 0, 0, like we mentioned earlier. That's how I solve it.